So for this problem, we need to check whether a character is a vowel or not. So the code we shown earlier used this method. So we first write a string that consists of all the vowel characters, both lowercase and uppercase, and then we check whether this character we are looking is in this string, appear in this string. So that's one way, but that may not be the first method that come to your mind if you are to first write it, because I think logically more straightforward fashion is to do this. So use if condition, use the if statement with a bunch of ors. So it's a vowel if it's a, e, I, or u, or y. And because we have both lowercase and uppercase, so instead of writing these 10 conditions all together, we can convert it to lowercase, and then we only need to write these six conditions all together. And here we use this operator in to check whether a character is in a string. So this is similar to checking whether an item is in a list. So again, one can very much view a string as a list of characters. And there are other ways, just like there are other ways of checking whether an item is in a list. We can count how many times this character appear in the string. And if it's greater than 1, then that means it appears in the string. And in our case, any character can appear either 0 or 1 times, because this string doesn't contain any character more than 1. We can also use this find function, which returns the index where the string appears. If it doesn't appear, this function will return -1. So by checking whether the return value of the find function is not -1, that means that this thing appear in the string. So all of these are equivalent for our purposes of checking whether a character is in a string. So they can all be used. And there's yet another slight variant. So other than this two-way is instead of listing the 12 character, we only list the lowercase. And then before we check, we convert this to lowercase, and then we do the check. So believe the final piece that we haven't really explained is this range that we use in the loop. So here we want to use the index going backwards, starting from the last character and then going forward. So then that means each time we will add -1 to the value. And when we are decreasing, then the semantic of the range is they will check whether they reach, they will stop before it become equal or less than this value. So let's try something on online GDB. So what I want to do is just to do some different range. So if we start from 10, and let's say we use this -1 as we use in our code, we just print out the value of I. So think about what this will output. So it goes from 10, 9, 8, 7 all the way to 0. So it's keep decreasing, and it goes to 0. It's because of this thing is -1. The ending point is -1. Suppose I change this to 0. So you should know what this will output. So we stop at 1. So we're not the ending condition is we never reach that. So we will stop just before we are about to reach that. So I can also do -2 and put something like 1 here. So this will 10, 8, 6, 4, 2. So before the next value will become less than 1. So yeah, and the index of last character is the length of -1, because the index start at 0. So that's that piece. So now This is the same version of code shown earlier, except that I commented out this break part. Um, I want you to think about what happens if I get rid of this break part. Yeah, so we've explained everything. So we're going backwards. If we find the letter, we will check whether it's a lowercase or uppercase. So let's see what this code does. And let's use some input here. So we're going to print a whole bunch of things because we will look at each character and see whether it's a letter. So the question mark doesn't do anything. The space doesn't do anything, but starting from A, the bananas, the last letter of banana, we are going to enter here, and we're going to check whether that's vowel or not. So we are basically, these correspond to A and, let's make it a little bit shorter. Let's just say apple. So it's going to print out the 5 things, and they correspond with the 5 letters. So the last yes correspond with A, P, P, L, E. So all the vowels correspond with the yes, and all the consonants correspond with no. So because we only want to look at one character, the last character, so we really should break at this point. So another thing that may not be immediately obvious is you may look at it and say, hey, here we are checking whether it's a letter. And here we are checking whether it's lowercase. So if it's lowercase, it has to be a letter. Do we really need the check to be a letter? So then this is a version that doesn't have that check. So I want you to think about what this version will do. In particular, if this is what will this output? It will output no. That's because after we remove that, we'll be checking every character. So we'll be checking the question mark. So the question mark, so SI, the first SI will be the question mark. And when we turn that into lower, it doesn't change. And the question mark doesn't appear in here. So we will go to the else branch. We'll print no. And then after that, we will break. So these have the effect of we are only looking at the last character, whether that's a letter or not. And if it happens to be a vowel letter, we will print yes. For anything else, could be a space, could be a question mark, anything else, we will print no, and then we will be done. So that will be incorrect.